Welcome to Chapter 2. So this chapter is about the chemistry of life. So we're going to start out pretty easy, just talking about the different types of bonds that you'll see. And then we're going to go into the chemistry of water, which is actually really unique and provides a lot of different things that help life as we know it exist. And then after that, we're going to talk about the four major organic molecules of life that you'll see throughout this class. And then we're going to finish up with some chemical reactions. Alright, so living things have atoms of different elements. So a lot of this comes down to a couple basic elements, maybe about 10 different elements as you'll see later on. But the main one is actually carbon. Okay, so oftentimes, scientists will refer to carbon-based life forms, or you'll hear that a lot in sci-fi, different kind of stories. But so carbon is a major part of life as we know it. So a couple definitions here. Atom is the smallest basic unit of matter. Okay. There are 118 different elements. So basically 118 different variations on the atom. Not all of them are stable, so some of them only exist for a tiny fraction of a second, but yeah. You also have elements. Again, elements are a different variation, a different type of an atom. Okay, you have 118 of them. They are found on the periodic table, so if you had physical science with me last year, you got familiar with the periodic table, I hope, and I hope you still remember that. If not, we're going to use it a little bit in this class, but it's not going to be as much as we used it last year. Alright, so some examples of our elements here. We have hydrogen and oxygen. These are two of the very important elements that you'll find in biology all the time. So, this is just kind of showing you a depiction of the two atoms. Oftentimes oxygen atoms are shown in red and hydrogen are in white. Carbon is usually black, nitrogen would be blue, phosphorus is purple, so on and so forth. Okay? But the three major ones are carbon, oxygen, and hydrogen. Alright, so atoms are made up of three subatomic particles. You have neutrons, which have a neutral charge. You have protons with a positive charge, and your electrons with your negative charge. Okay? You also have inside the core of the atom, you have a nucleus. That is where the neutrons and the protons hang out. Okay? So the nucleus has neutrons and protons. You have a neutral charge and a positive charge. So what charge overall will the nucleus have? It will be positive. Okay, so the electrons are basically hanging out on the outside of the nucleus in what are known as energy levels. So collectively, those energy levels are called the electron cloud. Okay, so they kind of just move around in the electron cloud outside the nucleus. Okay, so this is looking closer in at an oxygen atom. Okay, so oxygen has 8 protons. Okay, so it has an 8 positive charge in the nucleus. This specific oxygen atom has 8 neutrons. That is the most common form of oxygen, though there is some variation. You can get 7 neutrons every once in a while. Okay, remember the neutrons, the number of neutrons in the nucleus can change without changing the identity of the atom, and usually without changing the reactivity as well. Okay? Now, a couple things to remember about the neutrons. Okay, we already said that they are neutrally charged. They can be forced out of the nucleus, if you remember the nuclear radiation, nuclear decay that we talked about last year. And the neutrons are really important to the atom because they actually separate out all of those positive charges. So if you remember, like repels like, okay? So positive two positive charges next to each other don't like being next to each other, so they will force each other apart. And if there were no neutrons in the nucleus, you'd have all 8 positive charges right on top of each other. And if, pretty quickly they would actually force each other apart and the entire atom would fall apart. So, neutrons, very important. This depiction also shows you 2 energy levels. Okay, so in oxygen you have these 2 energy levels. The first energy level, the innermost one, can only hold up to 2 electrons. So your first 2 electrons will go into the inner energy level and then build outward from there. So oxygen, a neutral atom of oxygen only has 8 electrons because it has to match the protons. Okay, so you have 8 negative charges and 8 positive charges. Right, so you put the first 2 in the inner level, and then each successive level, energy level, can hold up to 8 electrons. Okay, so you've got your first 2 in the inner level, and then you've got your outer level. You only have 6 electrons left, so all of them go into that outer level. Okay, so this is an oxygen atom. Alright, and then some more definitions. A compound is made of atoms of different elements chemically bonded together. Okay, you can have multiple atoms of the same element bonded together, but they are still just called elements. Okay, as long as it's just a single type of element. You start adding in more types of elements and bind them together, and that's when you get compounds. So, example, water, H2O. You're going to see this a lot in biology. It is one of the most important compounds when we start talking about life. And I keep saying life as we know it because there is that question about if there is life on other planets, is it going to look the same way that it does on Earth, or is it going to be vastly different? So on Earth, water is incredibly important for life. So a couple things to point out about water, and we'll go more in depth into this in the next the next section. But you do have your 2 hydrogen atoms chemically bonded to one single oxygen in the middle. Okay, and you do also have charged regions, okay, partially charged regions on this molecule. So the oxygen, remember, is called electronegative. Okay, so it kind of pulls the electrons towards it, and that means that the hydrogens get a slight positive charge. Okay, that'll become really important in the next section. Another compound example is bleach. It's 1 atom of sodium, 1 of chlorine, and 1 of oxygen. Okay, methane. All right, so methane gas. It's CH4, so you have 1 atom of carbon, and it's actually sitting right in the middle of 4 atoms of hydrogen. And then carbon dioxide. So this is another really important molecule that you're going to see a lot in this class. Okay, so carbon dioxide is 1 atom of carbon, right smack dab in the middle here, the blue one. And then you have 2 atoms of oxygen, the orange ones on the outside here. And this image is actually depicting the bond between these atoms. Okay, so we're going to talk about bonds in a little bit, but here you can see that these 2 atoms are sharing 4 electrons in their outermost energy level. Generally, it's only the outermost energy level that will react, and it's the electrons moving between atoms that causes that chemical bond. Okay, so here you have 4 electrons between the oxygen and this first carbon, and then you have 4 more electrons between this oxygen and the carbon. Okay, so the carbon atom brought 4 electrons in the outer level into this bond, and each oxygen brought 6. Okay, but both elements want to have 8 in their outer electron energy level. So that's why they start sharing these. Okay, so if you count the ones that are associated with the blue, okay, you've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this carbon has 8, and you can do the same with each oxygen. So you got 2 here, 2 here, and then 4 here. So each oxygen has 8 in the outer level. So all of these atoms are happy. All right, ions. So ions are atoms that have gained or lost 1 or more electrons. Now, it's important to remember this is not talking about losing or gaining protons. Okay, if you lose or gain a proton, you're actually changing the element. So if you're talking about ions, you're just talking about the movement of electrons. So ions will have either a positive or negative charge. Okay, so atoms generally have just a neutral charge, but ions are where you get the positive or negative. So when you have a positive ion, you've lost electrons. Okay, so you're losing a negative charge, which means your atom becomes more positive. So, for example, with that oxygen atom that we looked at a little bit ago, okay, if you have 8 protons and 7 electrons, so you've lost an electron, that's 8, positive 8, and then plus negative 7. So you end up with a positive 1 charge. Okay? And then on the flip side, if you gain an electron, okay, you're gaining a negative charge, so you're going to get more negative, right? So you get a negative ion. And then these both have very specific names. Positive ions are cations, okay? One of my former students actually told me the way he remembers this is that cats have paws, so it's a positive ion is a cation. Yeah, I'm not the only one coming up with these puns here. And then negative is called an anion. Okay, anion, anti, I remember it as, it sounds like Anakin, anion, Anakin. Anakin Skywalker, who ends up being Darth Vader, and he can use the Force, which ends up being a negative thing. I know that one's a little bit more involved, but either way you remember it, either it was the positive, because I like saying that, or the negative in Anakin Skywalker. Okay? Alright, so this is a neutral atom here. Okay, so we have 6 protons, 6 neutrons, and 6 electrons. So with the protons here, you get a plus 6 charge. With the neutrons, there's no charge. And then the electrons give you a minus 6 charge. Okay, so plus 6 and then minus 6 cancel out. Your charge on this atom is 0. It is neutral. Okay, this one, you have 5 protons and 6 electrons. We're going to ignore the neutrons because they're really not going to change anything here. Now, interesting thing to remember here, okay, you have 6 protons here, you have 5 protons here. And remember, the protons, the number of protons determines what element it is. So these two are different elements. Okay? You have 5 protons, you have 6 electrons. So it's a plus 5 and a minus 6. Add them together and you get a negative 1. So this atom is negatively charged because it has more electrons than it does protons. And here, okay, now we're back to our original element, right? So we have 6 protons, 5 electrons. So it's a positive 6 plus a negative 5. So you have a positive 1 charge. You have more protons than electrons. And this is where we're going to pause on this first part of the video. So pick up in part 2.